And metals are what? Conductors. They are not electrolytes. Oh, madi. Type acids. Aqueous acids. Aqueous acids. Even though pure acids are covalent, but when they are in aqueous state, they can break into ions. You call that process dissociation. Okay, Chandita. Okay. Right? So those are how explain currently is a logonometrically right? Put a diagram with a look what on the put up space in a guys. Draw the diagram big and use the rest of the space around it to put these definitions correctly nicely. Huh? So you need to know these things to do the electrolysis, right? We are done with okay. Electrolysis करने के लिए तो हमें मैं आपको जानते पहले. So now don't wait until another day to study. Then mama make a brain निकल दाल. अरे okay. So let's move into the other part of this diagram. Now the electrolyte has ions, as we said, they have moving ions. Then surely the positive end will attract which ions? Negative ions. You know, negative ions are called anions. right? And the negative end will attract cations. Right? So the anions are attracted by anode. That's how you remember. I can see most of you remember electrolysis in a different way. ඔගොල්ලෝ පාඩම් කරන්නේ positive electrode is anode. That's how you study. Right? That's okay. But the best way to study is this. Anode attracts anion. Or since anions are attracted, anions are attracted, it is called what? Anode. In order to attract anions, it has to be what charge? Positive charge. That is a more logical way of remembering. Here, cations are attracted. Therefore, it is cathode. Cations are attracted, so it is cathode. So in order to attract the cations, cathode attracts cations. Cations are positive, therefore the cathode has to be what pin charge? Negative. You understand? And then you remember my mnemonic, anox. That means at the anode, it's always what process happening? Oxidation. And you know oxidation is loss of electrons. At the cathode, what is? Red cat. Right? That means reduction at the cathode. So those are the basic information that should come to your head when you are going to do electrolysis. Basic info.
Mobile lines.
Sorry?
Mobile lines.
Hmm?
Mobile lines.
Yeah.
Consider that.
Cathode. Then how many moving lines? Yeah, mobile lines. ලස්සනට ලියාගන්න නෝට් එක ලස්සනට ලියාගන්න ඔළුව කෙලින් කරගන්න පොන්ද කෙලින් ලියාගන්න එතකොට තමයි මේ යන දේවල් මයින්ඩ් එකට යන්නේ මෙමරි වැඩි වෙනවා. Right. So these are the general stuff that you need to know about. Right? Now, here we go to the next page. Definition of cathode. Cathode is where the reduction happens. That's the definition. Electrode at which the reduction of cations takes place. This is your cathode. In a non-negative definition, in what the
Electrode at which oxidation of anions.
yeah. Then that's a big program. Alright. Let's write the process. What is the process happen at the cathode? It's already there in the definition. But only in detail. Can somebody tell me one statement about the whole process which takes place at the cathode?
Unstable.
Not bad, not bad. Abhishek का टिका मत क्या वो पांती दिली हुए करे. Okay, let me explain. What are attracted? Cathode attracts. Cathode attracts cations, right? Which gain electrons to undergo what process? To undergo reduction. Process it. Right? What's the process? Cathode attracts cations which gain electrons to undergo reduction. So then tell me what happens at the anode. Especially anode begin to undergo oxidation. Very good. Again, yeah. These are the basics of electrolysis. So don't try to do electrolysis just by doing by hearting, right? It's not very effective. Only the temporary. Now, believe me, this table is the most important table of this lesson because it will summarize the whole lesson, right? And whatever information in this table will help you to handle all the examples that you're going to learn. Let's try to write down the common reactions at the cathode, which will be used in all the examples you are going to do today. Right? May reaction set take out a pull one electrolysis current. What is the most common reaction at the cathode? Hydrogen ions. Hydrogen ions. Hydrogen ion become what? Hydrogen ion become, right? Hydrogen ion become normally what? Hydrogen gas. In gas, that's why you need to put 2 hydrogen ions. So you need how many electrons? 2. So it's reduction. The most common reaction. ඊට පස්සේ ඔයගොල්ලෝ syllabus එකේ දීලා තියෙන most common reaction එක මොකක්ද? Copper 2 plus. Copper 2 plus will gain 2 electrons, will become what? Now it's a metal. You don't have to write copper 2 or anything, just copper. Right? What's the next most common reaction you have written in electrolysis? Cathode decay. Aluminium. We learned that under aluminium production, aluminium extraction. Aluminium is 3 plus, you need 3 electrons and then you write like that. Right? And all of them are reduction. Cathode decay any reduction. It was sodium. I am writing this in order, the order of the the possibilities that we have seen these reactions in the past papers. Right? Now, these are the four main cathode reactions. What are the other reactions? Lead, zinc, right? Lead, zinc, right? Anything such as chromium, right? You can write any positive ion. There is a possibility that it can take electrons and become its metal. So it's very easy, right? You just need to know the charge of the ion, put the number of electrons related, and then write the reaction. So out of all the reactions, what's the odd one there? What's the odd one? Hydrogen, right? Hydrogen again not metal, and it gives you a molecule other than the metal. Think about the anion anode reactions. All right, so how many electrons you need for the lead? 2 electrons, you get Pb. Zinc 2 electrons, Zn. Chromium 3 electrons, it's going to be chromium. Right, anions. What's the most common reaction again? Anions. Hydroxide ions. Right? Chlorine ඊට පස්සේ තියෙන්නේ. Now, all these cathode reactions, you can derive. By heart කරන්න ඕනේ. Cation charge එක දැක්කොත් what derive කරලා ලියන්න පුළුවන්. Right? But hydroxide ion, don't try to derive. It's only one I asked you to what? By heart. Make a by heart current. Four hydroxide ions will undergo oxidation by giving 1 oxygen, 2 water, and 4 electrons. Right? So please by heart. The anode, since we are dealing with anions, the reactions are a little complicated. Because the anion and non-metals do not exist in atoms, they exist in metals. Right? So then what's the next most common one? Chloride ion will turn into Cl2. So you put 2, you have minus, and then you get 2 electrons. What's the next most common reaction that you have to write in the syllabus? Oxygen, I believe. You're close, but you're monoxide. Oxide, not oxygen. Oxide ion. Make it tricky. This will give oxygen gas. So it has 2 oxygen atoms. Therefore, you put 2 here. May charge you need 2 atoms. Now you have overall 4 minus. Therefore, 4 electrons has to be put out. මේ ටික මතකයි නම් ඔයාලා හරි ලේසි electrolysis කරන්න. What are the other common ones? Br minus becoming Br2. 2 Br minus Br2 2 electrons. I minus becoming what? I2. 2I minus putting 2 electrons out. Okay, these are the common reactions at anode. Write it without mistakes. Huh? Common reactions at the anode. Okay. Right. Now you close the book. I wrote 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Close the book and try to write them in a different paper without looking at it. You can use the last page. බලන්න නැතුව ලියන්න ඕනේ. බාහිර බල බල ලියන්න බෑ. එකපාරට වැහුවා ලිව්වා. You just remember you have 7 in the cathode, 5 in the anode. එහෙමයි අපි help කරන්නේ memory එකට. ලියන්න බලන්න. by heart කරලා ලියන්න එපා දැන්. common sense වලින් ලියන්න. See whether how many you can write straight away. Seven. In total 12. Right, no? And he managed to write all 12. Oh, oxygen. Okay, so now then huh? Mother again. I took an oxygen reaction. So please do it until you remember what you have. So reactions clear, right? Reactions clear. මතක නැත්නම් බැලුවා ආපහු try කරන්න. Okay. You can check your answer with the right. You can check your answers with the right. You can see whether how many are correct. If they are not correct, rewrite it. Rewrite it. Then self realization conversion of වැඩ ඔය step එක ලියන්න පුළුවන් වෙන්න ඕනේ electrolysis කරන්න. All right. So let's go to the types of electrons. Electrons, inert means inert electrodes do not take part in electrolysis reaction. Do not take part in electrolysis reactions. Right? Listen to me about the active electrons. Even though they are all active, they are only active at the anode. Right? So it has to be kept as the rule number 1 in electrolysis. If we use active electrodes means what? Any electrode other than graphite and platinum. Any other metal electrode, right? Any electrode other than graphite and platinum. Right? Cathode, no change. Right? It's the anode depletes. Right? Active means the anode gets oxidized, not anions. Not anions. Are anions වලට chance එකක් නැහැ. අර අපි උඩින් ලිව්ව anions වලට chance එකක් නැහැ. Anode එක metal එකක් වුණා. Right? So anode gets oxidized, right? Not anions, and depletes. And depletes. And depletes. Right? So example, surely graphite and here platinum plus all the cathodes are inert. Cathodes are inert. Right? Okay. And then active electrodes, all metal anodes. All metal anodes. දැන් හිතනවා copper දැම්ම කියලා anode එකට reaction එක මොකක්ද? What is the reaction? Copper will become right? Listening skill එකට. Copper will become what? Copper 2 plus and 2 electrons. Lecture කියනකොට ලියන්නේ ඇයි එයා notes දෙන්නේ right? Campus lectures වල notes දෙන්නේ activities කරන්නේ lecturer side එක දාන්න එයා කියයි යනවා. He is just telling all these stuff, right? He doesn't care whether you write or not, whether you study or not, right? Since that you miss the note, you have to write. So you write, and later on you go home and then take the reference book read and try to understand what he said, and you make your own notes, and that's how you learn in university. Right? Sometimes they give you, most of the private universities, they give you printed note. Printed note එකක් දෙනවා. Right? හැබැයි unless you ask questions from the lecturer at that moment, or maybe separately, he is not bothered explaining so that the students have what? Understood. Because his job is to deliver the content and finish the course and go. The teachers තමයි අහගන්නවා, ලියන්න එපා, මේ විදියට මතක තියාගන්නවා, අර විදියට කරනවා, මේ විදියට කරනවා කියලා කියන්නේ ටීචර්ස්ලා විතරයි කියන්නේ. හරිද? ඒ ටීචර්ස් කියන විදියට කරන්නේ. එතකොට ඉම්ප්‍රූව් වෙනවා. right? අර විදියට කැම්පස් ගියාට පස්සේ කරන්නේ. එතකොට හරියි. right? ඒ විදියට ඉස්කෝලේදී කරොත් මේ දැන් තියෙන දේ කරගන්න බැරි වෙනවා. If it is magnesium, magnesium 2 plus 2 electrons. Zinc, zinc 2 plus 2 electrons. හරිද? node එක metal එකක් වුණොත් deplete වෙනවා. oxidate. No chance for anions. Yeah. Hey, Benson is here. Okay, so now we have done with all the basic stuff. So let's quickly go for a video and try to understand this. Okay. Let's see how the electrolysis is done. This is the same video that I showed you in your grade 9.
The Earth's crust contains many compounds. But the compounds themselves aren't as useful to us as the elements they're made up of. The Earth's crust contains many compounds. But the compounds themselves aren't as useful to us as the elements they're made up of. This rock contains aluminium oxide. Split the aluminium from the oxygen and you have one of the world's most useful metals. You can split a compound using electricity. The idea is to pass an electric current through it, a process known as electrolysis. A circuit is set up using 2 carbon electrodes, an ammeter and a power supply. The white powder is lead bromide. Switch and a power supply. The white powder is lead bromide. Switch on the power supply and nothing happens. The ammeter reads 0. Solid lead
Testing. Testing. No. I was worried about the echo. We'll make it speak again. How is your hand on it?
Yes, sir.
Huh? Take your mic in. Right. Okay. Let's. Then let's basic one.
bromide doesn't conduct electricity. It needs to be molten. Lead bromide melts at 370 degrees Celsius. Switch on now and a current flows. In this circuit, the electrode on the right is positive. The one on the left is negative. As electricity passes through the molten lead bromide, chemical reactions start. On the left, at the negative electrode, nothing appears to be happening. But at the positive, bubbles mean a gas is being produced. Placing small tubes around the electrodes traps any gas, making it easier to see their colour. What could the brown gas be? The gas is bromine. Although nothing obvious appears to be happening at the left-hand electrode, pouring the molten lead bromide away reveals a small silvery metallic bead. This is pure lead.
And fallen down to the nickel.
So, passing an electric current through molten lead bromide breaks it down into the elements lead and bromine. To work out why this happens, imagine you can see the charged particles, the ions, in the compound. There are positive lead ions and negative bromide ions. Once the power supply is switched on, the lead ions are attracted to the negative There are positive lead ions and negative bromide ions.
So this is before the current is applied. We switch it, right? The ions are randomly moving, evenly distributed, right? Once you switch on, only the ions will what? Move according to their charges. Right?
Once the power supply is switched on, the lead ions are attracted to the negative electrode. The bromide ions are attracted to the positive electrode. Lead ions pick up electrons. They lose their positive charge and form lead atoms. Bromide ions give up electrons. They lose their negative charge and become bromine atoms. These form a gas. Electrolysis of lead bromide only works when the compound is molten. Why doesn't it work when the compound is solid?
All right. So you go to the next page and do the activity. I'll show you the next page. Now answer this. Yeah.
So,
Yeah.
so what color is the gas?
You saw right.
Sorry.
What are they? Take a brown. Brown is like. Sorry, anode cathode reactions so clear because they haven't asked, but you write the anode cathode reactions also. Write down the anode cathode reactions. Let me see whether you can apply what you just learned. First of all, answer the questions given. Write down the anode cathode reaction without making mistakes. Then nickel part anode, anion unknown, anion has to undergo oxidation. Cathode the cation should go, cation should undergo reduction, getting electrons, right? Might taking the process right? Good. Then you have activity completely covered. So the bulb will not light until the lead bromide has melted. Why not? Solid lead bromide ions cannot move, but molten, yes. What will be seen at the anode? Brown gas and also brown liquid. Red brown is also correct. Name the substance B bromine. What will be formed at the cathode? Molten lead. Molten lead. And then I asked you to write the two reactions. The two reactions were in that table, like Br minus becoming Br2, 2 electrons, to Br minus, rasant liyan neva. Cathode Pb2 plus 2 electrons lead. But when you're writing anode cathode කියලා වෙනම ලියලා ලියන්න ඕන නිකන් ලියන්න බෑ. හරි? And then you complete the next task. Avisha, you all right with that?
Yes, sir.
Now you complete this. So you basically what you have to do, if it is only molten, you are lucky you have only 2 ions. There's nothing much to apply. And then write the anode and cathode reaction. Electrolysis is an easy lesson, right? Grade 9 knowledge make your observations real knowledge. You have to write the observations at the cathode and anode. You can predict. And one observations.
Observations.
Oh, observations there.
Observation and
එහෙම ගියේ කීතල දැන් ටයිම් මදි ඔය කතන්දර කියන්න. දැන් පුළුවන් ඉතින් ලියන්න ඕන. නෑ නෑ ඉන්නවා. මම යන්න කියලා කිව්වේ නෑ. පොඩ්ඩක් මේ තනියම වැඩක් කරන්න පුළුවන් වෙන්නත් ඕනේ ළමයෙක්ට. හැමතිස්සෙම මේ යාළුවෝ මත් එල්ලීලා ඉන්න බෑ. Right? Yeah. Chlorine though. Pale green. Right. Stop talking. Let's discuss. Sodium plus electrolyte. Please correct your answers. 1 mark for each equation correct. And what's the observation here?
Observation.
No observation?
But molten.
Follow my molten sodium. එහෙම කියන්න බෑ. කොහොමද ලියන්නේ?
Molten sodium deposits.
Molten silvery metal. ඒක නේද ඔයගොල්ලෝ දැක්කේ? Observation එකේ. That's what you saw, right? Huh? Sodium ටත් ඒකම තමයි කලර්. That's why you can't confirm it's like particular metal. The 2 electrons and chlorine. So what you get here? Pale green gas. Right? Abhishek, what did you Huh? Zinc part? Zinc part. Make up the molten silver metal. Right? So magnesium 2 plus will take 2 electrons and become magnesium. The molten silvery metal. And bromide, you saw, right? Red brown liquid and red brown vapor. Gas, the harna vapor can red brown liquid and vapor. Orange ලියන්න බෑ. Orange අපි ලියන්නේ bromine මොකක්ද? ඒක correct කරගන්න හරියට හිතෙන්න. අපි orange ලියන්නේ bromine මොන වෙලාවේද? Mesolia mass කීයද? Bromine aqueous. When bromine is dissolved in water, you write orange brown. Right? But when bromine is in its pure form, it's red brown. Right? And here we have zinc, zinc 2 plus, iodide ions, right? Zinc 2 plus has got 2 electrons and zinc. Then ඕගොල්ලන්ට තේරෙයි ආපෝ මේ අපරාධ electrolysis අපි ආවේ. මේක මාර ලේසියිනේ. එහෙම කියලා නෑ මේක ලේසි උනේ මේ lesson එක හදලා තියෙන plan එකේ. Right? සමහර ළමයින්ට එන පොඩි මේ mental case එකක් මේක වාගෙන යනකොට මේක දැන් හරි මම හරි මට පුළුවන් කියලා හිතලා ඊට පස්සේ give up කරනවා. ගෙදර ගිහිල්ලා බලනකොට ආපහු අයියෝ electrolysis ආපහු බැහැ. That because in the middle of the lesson you feel I am okay on this. That's a fake confidence. Right? ඒකෙන් අන්තිම වෙනකන් හොඳට අහගෙන ඉන්න. Right? ඒක ඔයගොල්ලන්ට විතරනේ මටත් වෙලා තියෙන්නේ. When I was a student I also get it. ඒකට scientific reason එකක් තියෙනවා. මොකද reason එක? කවුරු හරි teacher කෙනෙක් හරි කවුරු හරි මොකක් හරි explain කරනකොට ඔයාගේ past memory එකෙන් effortlessly knowledge එක එන්න පටන් ගන්නවා brain එකට. එතකොට ඔයාලට හිතෙනවා මේක මම දන්නවනේ. We know this. No. Somebody else made you to remember it in front of you. It doesn't mean that you know. Is that clear? ඒකින්ද ඒ confidence එකේ ඔයාගේ enthusiasm එක drop කරගන්න එපා. මොකද? දැන් මම ගන්නේ fake confidence එක කියන්නේ ඒ confidence එක ආවට එතනින් lesson එක නතර කරන්න එපා. මොකද? I mean, how do you continue to keep your enthusiasm? That's what you're asking. ඒ ප්‍රශ්නේ හරි. නෑ mind control නෙමෙයි. The first thing, main thing to overcome it, know that there is something existing. Right? ඔයාට දැන් මේක පුළුවන් කියලා දැනෙනකොට ඔයා තේරුම් ගන්න මේ කවුරු හරි වාට මේ මතක් කරලා දුන්නා. Right? ඒක නිසා I should keep on listening actively. Right? Rather thinking that I know this. Right? Or another way, so if I feel now I am remembering what I learned, let's do the rest of the examples without errors. If you can do it without errors, yes, now you are learning. Right? Errors තිබ්බත් කමක් නැහැ. නිකන් ignore කරලා මේක ඕනවට එපාට කරොත් ඒ කියන්නේ you are falling into the same boat again. Right? Okay. So molten silvery metal, why is always molten? Because we are heating, you are melting ionic compound, right? And then iodide ions, I minus will become I2, right? 2 electrons. Color එක කියන්න බලන්න.
Purple given.
Yes. Romet මට කියන්න බලන්න color එක. What? Dark brown. What do you guys say? Purple vapor. Others? Light brown. Pale purple. Yes. Iodine के काले का पता है?
So a color between purple and brown.
Color between purple and brown. Right? एक मार काले का. Right? ඔයා shape එකේ answer එකක් දෙන්න බලන්නේ. බේරෙන්න. Answer එක මොකක්ද? The correct answer is purple vapor. Very correct. දැන් brown කිව්ව අයට මොකද ප්‍රශ්නේ? ඔය කිව්වේ iodine ගේ මොන color එකද? aqueous color එක. Solid නෙමෙයි. Iodine is a tricky one, na? Iodine has many colors. It is gray in solid, shiny gray in solid, purple in vapor and in organic solvents, brown in dark brown in aqueous solutions. Therefore, it's tricky, right? ඒක ඉතින් ලියා ගන්න ඉතින් මගේ දිහා කණ්ඩ වගේ බලන් ඉන්නේ නැතුව. It's not I made iodine to this world. That's how iodine is. Right? The method ගන්න ඕනේ, it's just molten heated situation. You get the purple vapor. So you have aluminium 3 plus and O2 minus. At the cathode, you get Al3 plus 3 electrons giving aluminium. At the anode, O2 minus giving you O2 and 4 electrons. So colorless gas bubbles. Colorless gas bubbles. And molten silvery metal again.
Is it possible to bring liquid oxygen?
Liquid oxygen, no. Because its temperature is minus 200, your tongue will get frozen and broken. Alright, I'll give you 5 minutes break before we go to the class. Just relax. Then නිදා ගන්නෙමු නිදා ගන්නවා. හරිද? break එකේ නිදා ගන්නවා lesson එක වෙලාව යන්න ඉන්න. හරිද? Navisha, you can just walk around and come back. 5 minutes break. All right. Hi, Giza. Let's get ready. Now, I saw a few mistakes in the previous activity. Now, some of you have, like, in the middle of your writing this, you become you are working in the subconscious mind and do a lot of mistakes. Again, while ලියනකොට පොඩ්ඩක් කියලා යනකොට දැන් ගොඩක් ලියන්න තියෙනවා. Last part එක ඔයාලා නිකන් ලියනවා, right? Without processing. For example, you have written O3 here. Within O3 ආවේ course. Right? ඇයි ඒවට O3 එතනට ආවේ? ඒ common mistake එක. Anybody can do that. Right? Within O3 තිබ්බ නිසා. Why didn't I care about the numbers here? These numbers are dealing with the valencies. Right? Here the numbers should deal with the charge of the ion and the respective balancing. Is that clear? Method numbers the valency calculation. Right? Just because you had 3 oxygen, you don't have to put 3 oxygen there. Right? Okay, mistakes. All right, so then here we go to the most important phase of this lesson where you learn the aqueous solutions. Aqueous solutions have several theories. Let's learn the theories straight away and then remember. Okay, so they will tell you that, right? And aqueous solutions, they contain H plus and hydroxide ions in addition to the rest of the ions, right? So for example, if you deal with aqueous copper sulfate, right? The positive ion, positive anode will not only get sulfate ions, it will get hydroxide ions. Aqueous copper sulfate, water that. And the negative side, not only copper ions, but also hydrogen ions are there. So in that case, if there is a competition for each ion to go, then there are rules. There are 3 rules. Rule number 1, at the cathode, the ion of less reactive element preferentially get discharged. What's the rule? The ion of less reactive element gets preferentially discharged. Tell me again. The ion of less reactive element get preferentially discharged. Otherwise, ions taking less reactive element account here. Reactivity series less reactive element tech. Is that copper or hydrogen? Copper. Why? Copper is below reactivity series. Now, by reactivity series, definitely remember, you need to remember, right? Okay. Then basically, you have to give me the full attention. Okay, right? Full cooperation. Potassium, sodium. What is the reactivity series? Tell me. Calcium, magnesium, aluminium. So how do you write this first 5? First 5 shortcut right? Start, look at the periodic table. Start from potassium, go to sodium, come back to calcium, go to magnesium, go to aluminium. Because down the group, metals are more reactive. Right hand side, metals are less reactive. So the most reactive one is most left and the down. Right? But we are not taking most left and the down. We are not taking the rest of them. So potassium, sodium, calcium, magnesium, aluminium. After that, we have the one of the non-metals out of 2 in the that is carbon. Carbon to pass in not the zinc, iron, and tin. Right? Zinc is used to galvanize iron. Therefore, zinc is more reactive than iron. Okay. So only the one that you have to buy heart is tin. Tin is below iron. That's it. After that you have lead දාන්න පුළුවන් වුණා lead in the bed. Right above hydrogen is lead. Right. Hydrogen පස්සේ coinage metals copper, silver, gold. එහෙම mind එකට දැම්මම මතක තියාගන්න ලේසි coinage metals, the coins are made, right? And the least reactive means most valuable. So then down you have gold, copper, silver, gold, right? Platinum floor, platinum tempo, yeah, it's more valuable than gold, right? Listen. Then according to the rule, copper is less reactive. Therefore, the copper ion is the one going to get reduced. The cathode decision is easy. Okay, right? Cathode decision is easy. Anode decision is the harder one. Anode has two lists, right? You have ease of discharge tables. You know, by heart current only, right? I can remember last year student gave me a mnemonics to remember it as I box N, right? I box N. The reason she made it's like this. I box for dilute, right? Iodide box means Br minus. Ox means hydroxide, and then Cl nitrate. Sn means sulfate and nitrates. Sulfate and nitrate. So this is the easiest to discharge iodide. Okay. So in dilute solutions, hydroxide is more capable of discharging than chloride. But in concentrated, only that two are going to change. Chloride has more ability than hydroxide. May list එක මතක තියෙන්න ඕනේ. Is that clear? Right? So write down the two lists quickly. The note is already here. What I gave as a shortcut is CC. CC for concentrated. Concentrated na chlorine. If you have chloride ions. iboxen කියන therapy. Now, I usually don't use meaningless mnemonics, right? But I came from a student, so that's good, right? මම නම් use කරන්න ළමයි කෙලින්ම periodic table එක use කරනවා. Then I include, identify the ones which are odd, and that makes memory fixed. Iodine, bromine, that flows chlorine, bromine, iodine, පල්ලෙහාටනේ තියෙන්නේ. ඒක හදිපැත්තලි iodine, bromine, chlorine. Right? It was a hydroxide, sulfate, nitrates. Anyway, they are not going to discharge. Right? That's the concentrated one. Dilute one, hydroxide is going to jump into between chloride and bromine. That's how I remember it. Then now go back to your back of the tutorial and see whether you can write down the list. Rules to normally end up on the rule again. Add-on selective discharge rule here. Go to the last page and try whether what we just wrote you can remember. check the banana. It's all about whether you can recall stuff, right? Recall current value, not Hari Prashna, you know. Not only once, you have to take it several times, right? But recently, we have somewhere around 15 seconds of good memory. ඕනම දෙයක් කියලා 15 seconds ඇතුළතදී හැවුවොත් කියන්න පුළුවන්. ඊට පස්සේ ඒක හොඳට මයින්ඩ් එක ගියේ නැත්නම් කියන්න බෑ. ඒකින්ද දැන් අරක දැක්ක නිසා within 10 seconds ඔයා ලිව්වොත් ලියන්න පුළුවන්. right? පොඩ්ඩක් වෙලා ගිහිල්ලා ලියන්න බලන්න. That's how our brain works. Write it several times and see. Not only once, close it from your hands and then write it again and see. These are learning, studying methods. Study don't cheat yourself. Don't forget the first one as well. The element of, the ion of less reactive element will distance, right? Okay, are you confident in that? And here is the biggest and the most important activity of the day. When the make a current load. If you manage to finish it fully, you can be happy you are done with 75% of electrolysis there. Right? That's 25%. Anyway, right? Listen, I'll do the first one for you. Concentrated sodium chloride. The ions involve sodium ions and chloride ions, H plus ions and hydroxide ions. And they are going to the cathode. And these are going to the anode. Then the reaction, you must do the decision. You must take the decision. Cathode, you decide hydrogen ions. Observation, colorless gas bubbles. Colorless gas bubbles. Unlike the previous electrolysis, you guys have to say the reason. Why did you decide hydrogen goes here? That's the rule, but not the general rule. Specify you have to say hydrogen is what? Less reactive than powder. Less reactive than sodium. So H plus ions get reduced preferably. Reduce readily. Another reason. You get it? In the product chloride ion or hydroxide ion concentrated CC, then it's chloride ion. You get Cl2 and 2 electron. Here the reason is different. Pale green gas bubble. Right? Pale green. Sometimes it's not very clear that is pale green. Right? Okay. And the reason for this is concentration of chloride ions is high. So it has more ease of discharge. More ease of discharge. right? The concentration factor again you always say according to the ease of discharge table, you say this one has more ease of discharge. And Avish, I'll send you the table in the chat. Can't give you unlimited time. I'll give you time till 10:15. Yeah. Hydrochloric acid වලින් කොහොමද ඉන්නේ H+ විතරනේ. Because water gives you OH minus. HCl is HCl. I will explain. HCl I will explain.
Used to find the reactivities.
Huh?
The way you find the reactivities.
මම කියලා කිව්වා. Potassium වලින් පටන් ගන්න. Potassium ඉඳන් aluminium වෙනකම් විතරයි first 5 you do it with that. Right? The other 3 using galvanizing and at the give me a second. Yeah, the less. Hey, no, लिया करते थे. So it goes down. Yeah.
If they say it was which is if they say it was concentrated.
You take it dilute. If they haven't mentioned it's concentrated, you have to take it as dilute. When they say concentrated, they will say concentrated. Yeah, keep HCl. Don't do HCl. Right? Don't do HCl.
What's the color of copper?
Molten copper. Why you use molten copper? There is no molten here. All are aqueous. Right?
Power is fluid cool.
How the pathway to the table.
You don't use dilute concentration because the cathode is so we use only one group. What is the rule? And inside the cathode, the next reactive makes iron of less reactive that will only go at and well over the bike even on depend. The keyword that it was diluted the information we should take. Don't take the other. It was diluted. Ease of discharge state for the cancer reason. एक वो अमेरिकन पे दिखा थे उन्होंने लास्ट पेज में ट्राई करा था मतलब डिलीवरी के थ्रू मॉडल की सेल बन गया तो वो आप डाइल्यूटर यूज कर डाइल्यूटर लेके तो एनोडिकली आयंस के तो मॉडल पड़ेंगे हम आयंस की भी आते हैं निकालने से
Zinc can be cathode, iodine can be anode. Because zinc iodine is one pattern anode. You get my point? Don't stay in your comfortable zone by class එක ආවට පස්සේ actively ඉන්න. දැන් ඒකට උත්තරය ආදයකින් කොහොමද කරලා වැඩක් නැහැ. ඔයාලට ලියාගන්න ඕනේ reactive series එක. ඒ කියලා දුන්න වෙලාවේ අපිට විකාර වැඩ කර කර ඉඳලා එතන එන්න එපා මේ ක්ලාසස් වල වගේ තමන්ගේ මොලේ විකාර වැඩ කර කර ඉන්න. හරියට එනවනම් වැඩේ කරන්න ඉන්න මහන්සි එක. notes එකක් ලියලා දුන්නාම ඔයාලට time එක ඕන නම් කියන්න like I will give you time, right? I never said like you have to rush. එක එක ලෝකවල ඉන්න එපා ඔයගොල්ලෝ ඇවිල්ලා තමන්ගේ මේ වැඩේ කරන ලෝකෙ ඉන්න. එතකොට improve වෙන්න පුළුවන්. reaction series එක ලියාගත්තේ නැත්නම් දැන් ලියා ගන්න please. ඒ ගන්න විදිහකුත් කියලා දුන්නා ඒක apply කරන්න. Yeah, you have explained the knowledge. You have. No need to say because diluted is diluted where? There has to be, when you say diluted, you don't have to say it's X, but it should be. Otherwise, diluted is what? So, but here the answer given with you. Cathode reaction. Cathode reaction මොනවාද? sodium because भौतिक restart right මෙතන ගන්න rule එක බලන්න ඒ හරිය මෙලෝඩියක් ફોકસ කරන්න නෑ ඒ ඔක තමයි වෙන්නේ යාළු එකතු වුණාම පිස්සු කෙලිනවා දැන් කොහෙද කියලාත් මතක නැහැ තිබ්බද ඒ අත දැන් මේ බ්‍රේක් එකෙන් පස්සේ එක්ස්ප්ලেইন කරපු ටික ඔය මුකුත් අහන්නේ නැහැ අර තියෙන ඒකෝ සොලියුෂන් නෝට් එක කියවන්න අපිට සෙල්ලමකට ගන්න එපා තමයි මේ ඔයගොල්ලෝ ලයිෆ් එකේ මේ ටයිම් එකයි සෙල්ලමකට ගන්න එපා. consider කරන්න වැරදින එක වෙනම දෙයක් right once you do it and you make mistakes that's quite all right. හරියට කරන්න මේ දියන් නොවන results all right so we'll check the answers then we switch I then I'm really unhappy about the people who are not putting the proper effort that's because you haven't listened to me right when we විකාර වැඩවලට එන්න එන්න එපා okay So diluted sodium chloride means you have sodium ions and chloride ions. Aqueous means H plus ions and OH minus ions. Right? And now you have these two. Make a liand pattern. Any child can write this, no? The cathode reaction. Why? The rule is less reactive. The ion of less reactive element will discharge. The method reason එක ලියලා තියෙනවා. මේක ලියාගෙන හතර වටේ හොයනවා මොකක්ද reason එක කියලා. Right? The reaction is 2H plus 2 electrons. So don't bring the anode selective discharge rule to this. Right? Okay. That's a common mistake students do. Right? So you have to remember the rule separate. So here the less reactive element hydrogen is less reactive than sodium. That's the reason. So then it's going to be the same results and the same reason. It's a shame, right? You have all these things here and then you can't write the same thing here. Right? You can't figure it out. So that's the problem with your alertness, not with your understanding. And here this diluted. In diluted, we learn that hydroxide ions have better ability to discharge rather than chloride ions. Right? It is taking up with select. So then it's going to be 4 hydroxide ions producing H2O plus O2, 2H2O and 4 electrons. Right? So now it's a new one. So then let me write observation colorless gas bubbles. Colorless gas bubbles. The reason is in diluted solution, hydroxide ions have more ease of discharge. Right? In colorless solutions, hydroxide ions have more ease of discharge. More ease of discharge. මේ ටයිම් එක අපි ඩෙඩිකේට් කරලා ආවේ ලයිෆ් එක ඉම්ප්‍රූව්මන්ට් අනේ මෙතන නිකන් වේස්ට් කරලා යන්න නෙමෙයි නේද? So here H plus and sulfate ions. Water has H plus and hydroxide ions. So there is nothing to write. There is no reason to write. You have only H plus ions, right? So hydrogen ions. ඔයගොල්ලන්ගේ මොට්ට කරලා තියෙන්නේ මේ ටීචර් ලියන දේම ලියාගනින් කියලා මොලේ අප්සෙට් කරලා තියෙනවා ඒකයි. So the colorless gas bubbles same, right? It's the same. There is no reason. The same observation, right? You have only H plus ions. You can say H plus ions for each cathode, right? And sulfate ions and hydroxide ions, same scenario. Colorless gas bubbles, reason is also the same. But reason is OH ions have more ease of discharge than sulfate ions. Here, right? It's the same story. Only at the end, what pain and and Indian. So diluted copper sulfate, you have copper 2 plus ions and sulfate ions, and hydrogen ions and hydroxide ions, right? The reaction, then we decide copper is less reaction. So copper 2 plus will take 2 electrons and become copper, right? observation. Now this is happening at high temperature or at room temperature. Make for solutions. අපි molten නෙමෙයි heat කරන්නේ මේ normal aqueous condition එකේදී reaction එක වෙන්නේ. So then when the metal will nicely deposit on the cathode, right? So මොකද observation එක? Pink solid deposits on the cathode. Reason later, you have to say copper is less reactive than hydrogen. So copper 2 plus will get reduced. Pink, brown. Pure copper is pink. Make around last to pink solid deposited. Brown. And hydroxide ions will be going same. You get oxygen. Ogolo same can the and ogolo reason reason reactions the hydroxide ions, colorless gas bubbles, right? What a Khalil Lian background, that's all right. Then if I think you know, they put the Liaga. Okay, so that's about zinc. Diluted copper sulfate. Now it's zinc bromide. Kind of confusing one, is it? Is it? No. Confusion. Then they make a zinc the H plus the less reactive. I mean zinc the hydrogen the less reactive. Hydrogen, right? Zinc is above hydrogen. Therefore, surely hydrogen is going to get reduced. Then who is going to get oxidized? Then don't you need the concentration, concentrated or diluted condition? Or that is only needed when what ions are present? Chloride ions are present. Right? Only chloride ions and hydroxide ions priority changes with concentration and dilution. If not, it's always the iodide bromide, the best. Therefore, surely it's a bromide ion. In chemistry, none of these rules are 100% applicable for every situation. Right? Depending on other conditions, get different catalysts used. Sometimes the reaction can be different from what you predict from our general rules. We all will be rules where the reactions will not set. Exam they might have given it's not bromide ion, hydroxide ion will go. We don't know. They can give. Right? In that situation, they will give you enough information. Colorless gas, bubbles shown and all these things. You don't decide with the bromide do not unknown. Example make a oxygen. So you have to adapt depending on information, right? Because in chemistry, no rule is 100% right. Applicable for all the situations, right? So observations here, again, the colorless gas bubbles. Colorless gas bubbles. Bromide ion becoming bromine. Then make a, listen, may heated the situation. Normal aqueous solution. Heat karlane. Then in a bromine, you will see what? Orange, brown solution, and also kind of brown vapor can be seen. Vapor because the bromine is anyway volatile. bromine anyway volatile. Heat කරේ නැත්නම් එයා evaporate වෙනවා. Reason එක දන්න ඕනේ hydrogen is less reactive than zinc. Hydrogen is less reactive than zinc. Right? Here, ease of discharge of bromide is more than hydroxide ions. You have to refer to ease of discharge table. Then having done all these, right? Having done all these, HCl is a tricky one. HCl, there is something unusual happens. Look, you have H plus and Cl minus. You have H plus and OH minus. Remember, this is an acid. Acid එකක් නම් what about OH minus concentration? High or very low? This is an acid. Acid එක ඉන්නෝනේ මොන ions? H plus ions. So hydroxide ions amount is very tight, right? So despite of whether it's concentrated or diluted, since hydroxide ions are very low, now the CC rule is not applicable. It's HCl, it's usually chloride ions. Take a special case එකක් ඒක වෙනම ලියා ගන්න ඕනේ. HCl is usually what? Chloride ion, whether it's concentrated or diluted.
In all acids, does it happen?
All acids, it won't happen because concentration is affecting only the chloride. Anith they won't affect nitrate, sulfate, they are well below in the ease of discharge table. So there is no problem with little bit of hydroxide ions even to get oxidized, right? That's a good question. Hydrogen. So then the colorless gas bubbles, hydrogen. The reason is there is no reason, right? Only H plus ions. Because observation, then pale green gas. The reason is hydroxide ion concentration is very low since it's an acid. So the chloride ions get a chance, but even though it's not concentrated. Okay, that's a normal case. The deviation. Right now. So we are at the end of this tutorial, right? And you are now here on that. So what are we going to do? We have to do electroplating very quickly, and we'll discuss the aqueous copper sulfate one. Sulfuric එකත් අපි කරමු. Sulfuric you already know. Sulfuric you know we did sulfuric. Most of the maybe I mean apart from HCl, right? Then sulfuric බලන්න let me write it again. Sulfuric you have H plus and sulfate ions, right? H plus and hydroxide ions. And the cathode, we better write again, cathode, H plus become hydrogen taking 2 electrons. Right, at the anode, hydroxide ions, sulfate ions, very hard to discharge, so then this goes. Make තමයි all specially understand කරන්න ඕන case එක. This is special case එකක් බලන්න. This is only taking 2 electrons, but this is releasing 4 electrons. In order to make the number of electrons same, I'm going to multiply this by 2. Then only you can balance these 2 equations. Abhishek is allowed. Now I'm going to add these two equations. Look at the surprising thing happens. You get 4 electrons. You get 4 electrons plus 4H plus 4 hydroxide ions. This side you get 2H2, O2, 2H2O plus 4 electrons. 4 electrons get cancelled out. Right? Listen. 4H plus and 4OH minus means 4 water. 4 water, 2H2 and O2 and 2H2O. 2H2 and 2H2O cancel out, you get 2H2O. So what has really electrolyzed in sulfuric solution? Is it sulfuric acid or just water electrolytes? Water electrolytes. Do you understand it? Right? So with water electrolytes, can you see 2:1 the ratio of hydrogen to oxygen is produced? That's why in this setup, you can see hydrogen to oxygen collected ratio is what? 2:1. Sulfuric, diluted sodium chloride. In both case, electrolysis give you 2:1 hydrogen to oxygen. Sometimes this is important in the exam to figure out what electrolyte has been used by looking at the ratio of the gases. Hydrogen to oxygen 2:1 and monovalent. If it is water electrolytes. HCl electrolytes look at HCl. HCl 2 electrons, 2 electrons. Therefore, both are same. 1 hydrogen and what? 1 chlorine. 1 to 1. You get 1 to 1. Okay, so those are the tricky stuff that you find in the papers. Now make a little bit. තමන්ට අමාරුයි කියලා දන්නවනම් මේ ලෙසන් එක මෙතන ඉඳ ගන්නකොට ඩිටර්මයින් කරලා ඉඳ ගන්න එපා. හැම ස්ටෙප් එකම මම මෙතන එකපාරට උගන්වන්නේ නැහැනේ ලාස්ට් ලේවල් එකේ. හැම එකක්ම ස්ටෙප් වයිස් ලස්සනට පොඩි එකේ ඉඳන් කියලා දෙනවනේ. හරි? හයිඩ්‍රජන් and මයිනස් මේක ලියවිලා. හරියට ලියා ගන්න මට පේන්නේ නම්බර්ස් හදලා ලියන්න එළියේ. මේ මොකද ලියන්නේ? මේ චිත්‍ර කොපි කරගන්න එන්න එපා. ප්‍රසන්ටි හොඳට බලලා ලියන්න මොකද්ද තියෙන්නේ කියලා. All right, so the most important thing that you understand this ratio depends on the ratio of the gases produced. Okay. Chemistry. Next Saturday, not this Saturday, next Saturday. එක workshop එකක් තමයි මෙතන කරන්න complete. We will do the most important 2 or 3 experiments.
Are we doing it?
මේක මේ ඕනේ මේවා එන්නේ නැහැ already practical paper එකේ. Already practical paper එකේ ලොකුම problem එක සමහර enthalpy change experiments ඔයගොල්ලෝ කරන්න දන්නේ නැහැ. ඒකින්ද question එකක් දුන්නත් ඔයාලට තේරෙන්නේ නැහැ නේ කරන්නේ. නේ? reasons ලියන්න තේරෙන්නේ. පස්සේ qualitative analysis එකක් දුන්නොත් එහෙම කරන්න තේරෙන්නේ. Right? So the main target is enthalpy change experiment, qualitative analysis experiment, maybe a titration. Right? Titrations just to understand how to do it and stuff. Because now the trend is not those calculations. Now the trend is more practical stuff in us. But make a current one. I want you to write the observations and especially likewise we learned there. I want you to write the observations that you get in the electrolyte solution. Electrolyte solution in a observations, and these two are graphite rods, graphite electrodes. This is copper 2 plus copper sulfate 8 plus. Anode cathode reactions and observations, especially electrolyte solution observation. You know, copper sulfate is blue color solution, right? Reactions clear.
So, the use of the refined electrolysis.
Yeah.
So the we have given the definition is they do not take part in activation.
Yeah. They don't react. The graphite,
Yes.
they don't react. But the normal anode and cathode reactions will take place. Ions break karla and the current. Oh, not bad. You wrote the reaction also, right? No, you can't cancel. The second we have power to plus, that side is never. No, hydroxide ion large reaction. I didn't want you to do the overall reaction if you have done. That's really good. Right? Overall reaction එක කරන්න පුළුවන් නම් හොඳයි. පොඩ්ඩක් ඒ වගේ step එකක් තියන්න ළමයි වැඩිපුර step එකක්. Don't stay in the comfortable zone. You came here to like change your results, right? Okay, so let's see how you are handling this. You have copper 2 plus ions and sulfate ions. ඔය දන්න මම මේ ක්ලාස් එක පටන් ගන්නකොට මම common reaction set එක දීලා පටන් ගත්තනේ. ඉතින් ඔළුවේ තියනකොට මේක ලියන එක පහළු දෙයක් නෙමෙයි. Right? So the cathode reaction is copper 2 plus, taking 2 electrons and you get copper. Then අපි පොඩ physical states දාමු ළමයි. Aqueous will become solid. So මේක අඳින්න plus minus එක පැත්තට copper 2 plus H plus එක පැත්තට sulfate ions, hydroxide ions. Then so you decide the reason you know copper is less reactive than hydrogen, right? මොකක්ද observation එක? Pink solid deposits, right? And anode reaction here is hydroxide ions and will give you oxygen plus oxygen gas plus H2O liquid and plus 4 electrons. So colorless gas bubbles. Now what happens to the electrolyte? You know the color of the electrolyte is blue. Why it's blue? Due to what? Copper 2 plus. So then what happened to the color of the solution? Fades. I fade blending. And then the copper 2 plus concentration is do you know why it's reduced? Because the copper 2 plus is going to deposit on it. Right? So then there's an extra explanation you write. Blue color of the solution fades. Blue color of the solution fades. The solution fades. That means copper 2 plus concentration decreases. The reason for that decreases as copper 2 plus is getting reduced. I mean, methanol reduce can be English reduction, maybe chemical reduction, right? Getting reduced. And I saw one person has tried getting an overall reaction. That's a very good attempt. You multiply by that 2 because you have 2 and write like this. 2 copper 2 plus aqueous, right? 4 electrons. This explains a lot of things because this is the overall reaction happens in the solution. You get 2 copper solids plus oxygen gas plus water, 2 water plus 4 electrons. Now the 4 electrons getting cancelled. Nothing else going to get cancelled. So this shows your solution. The color is fading because copper 2 plus is used. තව එක unseen change එකක් වෙනවා solution එකේ. Can somebody figure it out? What is it?
Solution concentration changes.
Solution concentration changes. ඒක කිව්වේ blue color එක අඩු වෙන්නේ concentration එක අඩු වෙන්නේ ඉඳලා. ඒක හරි. තව එකක් තියෙනවා. No, what is anyway there? Acidity increases. ඇයි ඒ? නෑ කොහොමද කියන්නේ?
Concentration of
Acidity increases because hydroxide ions are what? Removed. That makes the hydrogen ions to get accumulated. So solution turns from neutral to what? Acidic. ඒකත් ලියන්න. Electrolyte turns acidic because hydroxide ions are removed, the H plus ions get accumulated. All right, so here we step into the next. මේක ඉවර කරලා තමයි යවන්නේ. ටයිප් එක බල බල ඉන්න එපා වැඩක් නැහැ. ඉවර කරලා යන්න. හරි ඉගෙනගන්න තමයි. Right? Now, right? Some of you guys are like, මම මේ බලෙන් ඕගොල්ලෝගේ ගෙදරින් මෙතෙන්ට ගෙන්න ගෙනවා වගේ. හරිද? ඔයගොල්ලෝ මෙතනට ආවේ ඔයගොල්ලන්ගේ රිසල්ට් එක වැඩි කරගන්න නේද? කෙමිස්ට්‍රි රිසල්ට් එක වැඩි කරගන්න. ඉතින් ඒකෙන් පොඩ්ඩක් මේක ඉවර කරලා ලස්සනට කරගෙන යන්න. හරිද? Right. So far, what are the things we know, right, as rules in electrolysis? These are the stuff that you should know. Anode, where oxidation happens and anions are trapped. Cathode, cations are trapped, reduction takes place. And in aqueous, less reactive element, ion of less reactive element undergo discharging at the cathode. In aqueous solutions, the ease of discharge tables should be working in the anode reactions, right? And then I taught you one extra rule at the beginning. What is that? Active anodes, right? When you use active anodes, what will happen? The anode will get oxidized instead of anions. That's the concept in under electroplating. Why? If you want to electroplate some metal on, let's say, steel jug, you want to make it looking silverish, right? Ornamental jug එක කරන්න ඕනේ කියලා හිතන්න. It can be easily done by electroplating. Keep it as a cathode and let silver ions to go to the cathode and get reduced on the jug. Anything, right? You know you guys are tired. Even I am tired. Revision class එකල් ඉවර කරනකොට මෙතන රැය කළා මාතේ. ඊදර යනකොට 12ක් පහුවෙලා. Right? Then have to get up and starting your classes and all the classes, all day. But we all are working on your what? Achievements these days, right? අන්සෙලා කරන්නේ එතකොට ඒක තමයි full effort එක දාලා කරන්න ඕනේ. හරි? දරාගෙන ඉන්න ඕනේ. Life එකට ඕනේ මේ skill එක. Right? So these silver ions will get attracted to minus and deposit on this. But these silver ions will run out now. Therefore, we have to put the anode as silver. Because when the anode is a metal, Anions do not have any chance to undergo oxidation. Suppose I use silver nitrate, both of them do not have a chance. Right? මේ දෙන්නටම chance එකක් නැහැ. Anode එකේ nitrate hydroxide ions, no chance. Instead of that, silver undergoes oxidation. මේවා අපි ලියලා පටන් ගත්තේ. Silver undergoes oxidation. Then at the cathode, silver and H plus will reach the cathode. Silver and H plus will reach the cathode. So who is less reactive? Cathode decay rule like less reactive element will undergo reduction. The ion of less reactive element. So the silver is less reactive. The balance make electrolyte take mukut vela naha. Ei anode එක deplete vela silver hadala තියෙනවා. And those ions have undergone reduction. So basically what happens, silver coming from the anode and has gone and deposited on the cathode. Right? The observations for the anode depletes. Anode depletes. Right? That means getting smaller, getting lighter. You can measure the mass and see. The cathode, there will be what? Silver nitrate. Silver deposit. Make a silver deposit, right? Silver deposit. Silver deposits. එතකොට electrolyte එකට මොකද වෙන්නේ? Electrolyte එකට මොකද වෙන්නේ? What happens to electrolyte? It stays the same. It's no change in concentration, right? So no change in color, no change in, because silver ions are. Okay. Clear. That's the concept of electroplating. Cathode එකට අපි දාන්නේ අපිට ඕන article එක. Anode එකට දාන්නේ metal එක. Okay මේ rule තියෙන තැන් වල මේ writing ලියන්න මේ empty space එකේ diagram එක අදින්න. Empty space එකේ diagram. And then you can try the next one with this. Metals on the oxidizing and non-metals they are oxidation and metals have more power to get oxidized. उनको तो कथा करते रहेंगे. Practical.
So after recirculating, why don't they wash it with soap?
I think may normal may electrolyte එකක් ගෑවෙනවා. So you have to clean it. මෙතන නිදා ගන්න බෑ. Silonitrate. Silonitrate. Zinc nitrate ගන්න පුළුවන්. ඊළඟ එක කරන්න. Zinc one, there is a special case. Now, just because of we are doing electroplating, don't like ignore all the electrolysis rules. Okay. මෙතන වෙලා තියෙන්නේ active anode. ජනිත වැඩේ කරන්න. Second එක කරන්න. ඔගේ special case එකක් තියෙනවා. Especially when you choose the electrolyte. මොකද molten තමයි ගන්න ඕනේ. ඇයි ඒ? aqueous ගත්තොත් වැඩේ upset වෙනවා. ඇයි upset වෙන්නේ? hydrogen ions එනවා cathode එකට. නේ? hydrogen ions ආවම cathode එකට hydrogen තමයි මොනවා වෙන්නේ? reduce වෙන්නේ. Then we don't get what we want, right, to happen. Yes. ඒකින්ද තමයි වාට AC current එක පාවිච්චි කරන්න බැරි electrolysis වලට. ඇයි ඒ? AC current එකේ හැම second එකටම 50 times 50 hertz නම් direction එක change වෙනවා. plus minus වෙනස් වෙනවා. right? plus minus වෙනස් වෙනකොට anode cathode මොනවද වෙන්නේ? වෙනස් වෙනවා. ඒතර cation anions වලට පිස්සු හැදෙනවා. ඇයි මෙහෙට මෙහෙට යන්න බලනකොට ආපහු මෙහෙට අදිනවා. මෙහෙට යනවා මෙහෙට යනවා මෙහෙට යනවා මෙහෙට යනවා. electrolysis දෙක. No. Deplete වෙන එක කියන තමයි metal එක දාන්න. The metal that you want to electroplate on another article. Cathode is where the deposit happens. So your article should be the cathode. So basically, the bucket is connected to this side minus this should be zinc metal. Make electrode එක තමයි ළමයි carefully choose කරන්න ඕනේ reason එක it should be zinc salt. හැබැයි වට aqueous salt එකක් use කරන්න බෑ. Reason, if you use aqueous salt, you get both zinc 2 plus and H plus reaching there. You want zinc 2 plus reduce. හැබැයි zinc 2 plus reduce වෙන්නේ නැහැ. Hydrogen ions ඉපොත් කවුද reduce වෙන්නේ? Hydrogen ions, because less reactive element will reduce. Therefore, don't use what? H plus in this electroplating. Always use something like molten zinc chloride. Right? So then anode, look at the anode, it's a reactive one. Anions don't have any chance of doing reactions. Chloride chloride will be coming to that, but no reaction. So zinc will get oxidized. And cathode, your zinc 2 plus will take 2 electrons and become zinc. So finally, there is nothing happening in the electrolyte, right? Zinc has deposited. Sorry. How do you do that? The reactivity of the metal. If the metal is more reactive than H plus, then the hydrogen because then the hydrogen is only getting what? Reduced. So there's in electroplating, you want to get your metal deposit. Therefore, then use molecules. But if the metal is below hydrogen, doesn't matter. Because it will deposit. Right? So all this information should be processed in your head. Right? Okay. So you can remember the plan I gave you, the extra classes, right? But we can't stay on the time 8 next week because some of you guys have single paper, right? Therefore, we decided to have the class at 12 o'clock, right? So it will be 12 to then 3 hours. 1, 2, 3. 3 hours current rate we'll start at 11:30. 11:30. 11:30. Single paper 12. We'll start at 12 and we'll do 2.5 hours, right? Because I have my normal class at 3 o'clock, right? And what are we going to do next day? We will be doing the remaining part of electrolysis. These 2 pages are homework. Take homework mark karaganda, please. Mark it as homework. Homework. Both pages are homework. And copper purification, aluminium extraction next day. That too will take only half an hour. After that, we will be doing past paper questions of electrolysis. Right? If time permits, we will be starting calculation. Right? And I'll be doing calculations for 2 days, and that's the end of the crash course. Right? Okay. අනේ මෙතනට එනවනම් වැඩ කරන්න බලාගෙන ඉන්න වැඩ කරන්න බැරි කාලේ ඉඳරි. හරිද? ඊට වැඩි හොඳ ගෙදරට පාඩම් කරන්න. Okay, I'll see you guys next week. Bye.